first, just some vocabulary. When you hear the word population, population refers to the entire group that is being studied. If you take a census, that is a survey of an entire population. A sample is just a part of the population. A statistic is a number that describes a sample, and a parameter is a number that describes the population. So what to know is the associations. That's the important thing to know. Look at the first letter. Sample goes with a statistic. A statistic is a number about a sample. A parameter is a number with a population, S and S, P and P. A parameter is almost impossible usually to obtain, because typically if you're measuring something, it is very difficult to make contact and record a number about an entire population. So parameters are very difficult to obtain. Therefore, that's why we have statistics, because a statistic deals with just a sample, a part of the population that you study, and then based on your findings, based on that statistics, now you can draw inferences based on the entire population. You can try to estimate numbers on the entire population. So here's ways to gather data. I'll let you read through most of this on your own, and I'll just highlight some of the key points here. When you're gathering data, what you want to do is to limit bias and increase randomness. The way that you limit bias is to be as random as possible. Okay, bias is where your sample would be skewed because of going one more way than the other. The example that I always remember is if you wanted to find out who likes reading, and you were to gather data outside of a library, as people walk outside of a library, that sample is likely to contain bias, because it is more likely that people in a library already like to read, and not too many people that hang out in a library probably don't like to read. I guess it's possible, but just not likely. So the way that you limit bias is to increase the randomness. There are some ways to collect samples. I'll let you read these on your own. These are 4 different convenience sample, a self-selected sample, a stratified sample, and a systematic sample. This is available for download. You can read through it. What I would point out, besides describing what each sampling method, this tells you that these could result in bias, and it tells you how this could result in bias. So you would figure out how to limit this. If you were to use these samples, you would limit the bias by avoiding these scenarios that they tell you that could create bias in your sample. To know whether students would like the council to sponsor a midwinter dance or a midwinter carnival. Drag and drop each word to classify each sampling method. Okay. So the first one, survey every 10th student on the school roster. So since there's a structured method that they're following, that one would be systematic, that they're following a rule. So that would be a systematic sample. Survey all students in 3 randomly selected homerooms. Okay, so since here we're grouping, it is random, but we're grouping the students by homerooms. This would be a cluster. Then survey 20 randomly selected freshmen, 20 sophomores, 20 juniors, and 20 seniors. So we're putting them in groups, but we're trying to make the groups as even as possible. So this one's going to be stratified. Survey those who ask for a questionnaire. That's going to be self-selected. So the people they're choosing to be part of the sample. And then survey a random selection of who those that happen to be in the cafeteria. That's just convenience. If they happen to be there, that would just be the convenience sample. Decide whether the sampling method could result in a biased sample, and complete the explanation for your reasoning. So on the first day of school, all of the incoming freshmen attend an orientation program. Afterwards, the principal wants to learn the opinions of the freshmen regarding orientation. She decides to ask 27 freshmen as they leave the auditorium to complete a questionnaire. So this sampling method is either likely or not likely to be biased, since the sample is random and blank of the freshmen are available to be chosen. So let's see. Afterward, she wants to learn the opinions. She decides to ask 27 freshmen as they leave the auditorium. Well, as long as they weren't sitting in a certain area based on anything particular, I would say that this is not likely to be biased, because any of the freshmen could have been chosen. All right, same thing. So the members of the school drama club want to know how much students are willing to pay for a ticket to one of their productions. They decide that each member of the drama club should ask 5 of his or her friends what they are willing to pay. This sampling method could be biased because the friends of the club members might be willing to pay more than others to go see their friends. Okay. Identify the population and the sampling method. A quality control inspector at a computer assembly plant needs to estimate the number of defective computers in a group of 250. He tests 25 randomly chosen computers. So the population is the entire amount of computers, so that would be all of the computers in the plant. And then choosing 25 randomly control. The computers didn't choose themselves. They weren't spread out in a cluster. It isn't every, like he didn't say every 10th computer, so this should be a simple random sample. And finally, same thing, population and sampling method. A manager of a movie theater wants to know how the movie viewers feel about the new stadium seating. She asks every 40th person who exits the theater each Saturday night for a month. So the population is going to be everywhere. The sample is who she chooses, but the population is all the people that go to the movie theater. And this is going to be systematic because she's following a rule. It's every 40th person.